How you doing? Today we'll be doing a Lewis Rossman type of video. I'll be talking about right to repair, having to throw away very expensive components because the OEM has locked out the firmware and you can't control this component with anybody else's stuff or any aftermarket stuff. There's just nothing available. What we're going to be talking about in particular is this guy right down here at the bottom, and it is a Waterway PD250 variable speed spa pump. It's based on a Waterway Viper pump, 2.5 by 2.5. I do believe these are like 2.65 or 3 horsepower total, 13.4 amps. It's a pretty expensive pump. When it was new, I do believe they sold for about $1,200 each. The real problem is they were designed to work with this Neo control made by Waterway that had a full motion graphics touchscreen, just like a cell phone. That's the only user interface for the motors. They don't have any kind of interface built into them like a normal variable speed pump would, which, as you see here, has been discontinued and for good reason. I've only seen about 4 or 5 Neo controls. Every single one of them went into the garbage. On this particular project, we replaced the Neo control with a Balboa BP2100, shown down here in the corner, and a Spa Touch 2 topside, which is full motion graphics touchscreen. Here's a better look at those components. Balboa is absolutely top of the line equipment. I use it in all my retrofits. The way these pumps work, to make them variable speed, the motor itself has to be a 3-phase motor because it's a brushless induction motor. You've got a VFD and an inverter that are actually part of the pump motor. They're an accessory. They're bolted to the top of it. To operate those, you have what's called a drive interface board. To operate that, you normally have some type of user interface, which is a little keypad. It has a display on it. You can set all your parameters, do whatever you need to do in there. These do not. Where that would be on the outside of the motor is just a blank cavity. There's nothing there. What I intended to do was to use two-speed pump outputs on the Balboa BP2100 and use 4 relays. Those 4 relays would go to the 4 discrete inputs on the drive interface board, which would normally be set to a specific RPM each discrete input. So you would have, by pushing the pump buttons, you would have 4 speeds. Both pumps originally were wired together and worked simultaneously. Was not able to do that because there's no way to turn on the discrete inputs. I would need some type of user interface, which I do not have unless I had a working Neo 2100 or whatever model it is, and a working Neo TP500 topside to get into the low-level programming of that drive interface board. The drive interface board that's in there is very similar to the drive interface board as far as architecture and size. The drive interface boards that are in the newer Power Defender pumps, the standalone pumps for swimming pools and things like that, they do have a user interface on the top of them. I don't have one, and I'm not going to spend $800 to $1,000 on a pump so I can take the user interface out of it and potentially ruin it. And there are no replacement parts. If you look at any parts breakdown for any of these pumps, they sell all the parts. They sell all the wet end parts, but the motor and the motor drive are all one assembly. You cannot purchase any parts. You cannot purchase any boards. Maybe if you're like a certified repair shop or something like that, the components are made by Nidec. Nidec makes all kinds of control boards for all kinds of stuff. You cannot find these particular Nidec boards. You can search by the part numbers. You're not going to find them. There's nothing available for them. What we wound up doing on this project was just installing 2 regular Viper 2-speed 230 volt pumps. And list price on those is about $900. You can find them on Amazon or other some other websites for $675, $750. I sold them to the customer at my cost, which is just under $500, just because it was unanticipated expense. So we're still $1,000 just to replace these two pumps. The way I wired them up was I just wired them up as regular 2-speed pumps. So instead of working simultaneously now, they work independently. So it winds up giving you first button push, one pump be low speed, second push would be high speed. If you push the other jet button, would be first push low speed, first push low speed, and if second push, first push be high speed with low speed, and then second push be high speed, which winds up giving you, 4 speeds. And the customer's actually very happy with it. He's very pleased with the way it works, just the fact that it does work. I really would have liked to have just, an hour labor and a handful of relays and a little box and reuse the cable that was already there, just a little 22 gauge cable that went to the RS-485 on those pumps. It would have been a lot easier than spending another $1,000 because these boards are locked out. We're going to go out into the garage a little bit, and I'll show you all these components, and I'll show you what I did to make this motor run. But it's not right. It can never, the way I have it running, you can never install this on somebody's system. You set yourself up for a lot of problems if they had a problem. So here's the rating label. You get no information off of that because the input voltage is single phase 230. It doesn't tell you anything about the VFD or the voltage of the motor, the actual voltage of the motor, or anything else. Here is the inverter and drive off of that motor we've been talking about. This is the lid. So this area right here is where the user interface would be. There would be a little door that flips up. You'd have some buttons and a screen, and you'd be able to set all your parameters and see what the motor was doing and all that stuff. It was never meant to be a standalone motor, and you can see they just have a plug where the cable would go through. This is the drive interface board, and right here are your discrete inputs. So that's where I should be able to hook up just a switch or a relay or whatever I wanted to do, and each input should be keyed to a specific RPM. These pretty robust drive. Underneath it here are some really humongous capacitors. I see a couple of inductors down in there. I've had the lid off of this. I'm not going to take it off now. It's too much work. This is where your line voltage will go in. This is where your RS-485 cable would go in, and it would hook up right here. So you'd have your ground and an A and B right there, the first three from the bottom. And should be simple. Like I said, on newer versions of this, you have to go into the setup and you have to actually tell the interface board that you're not going to be using this, that you're going to be using these. And there's no way to do that on this because we have no interface. I've got a VFD here that I bought off the Jungle website. It was about 85 bucks. The Jungle website, let me give credit where credit's due. This is Derek Bierry from Vice Grip Garage saying I stole that. And here's the motor with the VFD that came from the factory removed. It's over there and sitting on top of a box. And it's just a 3-phase motor, doing 3-phase motor stuff. Out of the box, this wouldn't run on its defaults. You've got to set these motors up to run, and I was just guessing at a lot of these parameters. Some of them I knew, other ones I just kind of trial and error. So get in here, the first parameter is going to be the line voltage, which here it's probably actually more around 235 to 240. I just left it at 220, that's the factory, that's the default setting. The second parameter, I'm sorry, the next parameter, which would be P001, is going to be the frequency of the input voltage, of the line voltage, which here in the United States is 60. The next parameter, I don't know what happened to the video right there, but the next parameter that was set was the intermediate voltage. And just through trial and error, it wound up being 48. It comes default set at 110, but at 110, that motor sounded like an internal combustion engine that was going to throw a rod. It was making some noise, so I just kept adjusting it down until the motor sounded good. I don't know what I just hit there. Let's go back here. So the next parameter, I don't have set, and P04 would be the minimum voltage. And I've just got that set at 0. This is going to be the maximum frequency, 42.6. So that'll be the max speed on the pump. And then I think we skipped over 5. So that is going to be, I think, the minimum frequency that the motor can run at. It won't run below 14.3. It really doesn't want to start operating below 20. And go back. I think that's going to be 8. Nope. Yeah, it's 7. So it really doesn't want to start below 20. One of my neighbors driving by with his noisy car. So that's pretty much how we got this bad boy running. So that's max speed. That's minimum speed. We can stop it. We can reverse it. If you watch the screen here, another parameter that you can set that I just left at the factory settings is the deceleration. So if you watch that screen, when I hit end, it's not just going to shut off. It is going to slow itself down. I'm glad I bought this inverter. It's cheap, but it'll be a good diagnostic tool. So if I go out into the field and I have one of these variable speed pumps that's not running, I'll actually be able to hook up to just a 3-phase section of the motor and see if the motor itself actually works or if it's a problem with the VFD, the inverter, and that'll be a good diagnostic tool. I'd like to come across a burned up or mechanically damaged newer version of this Power Defender, one of the pool pumps, so I can snatch the drive interface board and the user interface off of it and see if I could actually get that drive working again back on this motor. That'd be pretty cool. And see if I could actually hook that one up to run the discrete inputs and work with any control that I wanted it to. But for now, I've got this motor and it runs. It might wind up on some kind of project someday, who knows. It was a good learning experience for me. I don't have a whole lot of experience with 3-phase motors, And really, I've done mechanical repairs, bearings and things like that on these. And some of these are fixed magnet motors. This is an induction motor. But some of these have fixed magnets in them. And they're pretty difficult to take apart, actually, because the magnets just want to grab everything in there. And you better make sure there's no iron filings or metal parts laying around, because it'll be in that motor and you'll be trying to wipe it off with magnets for the rest of your life. Especially if the bearings are going bad, all that bearing dust will be stuck all over the inside of the motor. You got to wipe it out real good. But this is, like I said, it's been a pretty good learning experience, and I'm just disappointed that Waterway will put out a product like this that had no other application except for when used with their control, which they no longer produce. I think they still do make the Neo control, but they do not make the top side. I'm not very familiar with them, so I don't know if the standard panels will operate these variable speed pumps or not. I don't think they will. Even if they did, you'd still have to program it, and that's not going to happen with the little teeny LCD screen with 3 characters on it. Not LCD, I'm sorry, LED screen with 3 characters on it. It's just one of those things where the consumer really takes a hit when you have to go out there, and the guy from Waterway doesn't have to stand out in his yard and explain to him why he needs to spend an extra $1,000. And it should have been more than $1,000. It should have been close to $2,000. But I don't put that off on my customer. Like I said, it was an unexpected expense. I wasn't going to make the customer cough that up. I just wanted his unit to run. I made enough money on that job, just in labor. And yeah, well, that's pretty much it for this video, and we'll see you on the next pump rebuild.